let me just start recording. So we're gonna do question 10 from November 2018. And I think we'll still have enough time because this is a very short question. And you said we should only do generators and motors, right?
Yes, sir. But if we have time, can we maybe just go through a few of the more difficult questions, like those, the 6 mark questions or like 5 mark questions? That's usually like the last question for the momentum and stuff like that, sir.
Oh, nah, for momentum and impulse.
Yes, sir. Just like the difficult questions, not like the first few.
Okay.
Just like the last few.
Let me just open this question paper. We're gonna find like our first maybe 5 mark question, and we'll answer it after answering that question. Is that fine? Yeah, and here it is 2.1.4. I think it is based on momentum. Wait, nah, this is Newton's law. So we can also, do you also want to do Newton's law?
Yes, sir.
Okay, so we'll just do Newton's law. Projectile motion is fairly easy, and this is also momentum. There's a 5-mark question at 4.3. So I think if we're able to do maybe this one for Newton's law, and if you're free tomorrow, because you said you're writing on Friday. So
yes, sir.
so if you're free, we can also have an extra 1 hour lesson tomorrow, because we could have had a 2-hour lesson today, but there's gonna be load shedding in 45 minutes. So that's a whole different situation. So yeah, basically here, the first question, 10.1.1, they want you to use the right hand rule. 10.1.2, they say state which principle or law that generators are based on. If I remember well, it's Faraday's law, but I'm pretty sure it. Sorry about that. Let me just move this elsewhere. Just want to move that elsewhere. Yeah, it's Faraday's law of electromagnetic induction. So generators and motors, like that, they operate on that principle. So then they state the energy conversion that takes place when a generator is in operation. So what happens is that in a generator, this coil, let me just start drawing. This coil is gonna rotate in the magnetic field, and when something is rotating, that's mechanical energy. Or when something is moving, that's gonna be mechanical energy, and that mechanical energy is used to generate electricity. So the energy conversion that takes place in a generator, that's mechanical energy to electrical energy. I'm pretty sure like that's a simple enough. That's an easy concept. So now when it comes to like generators and motors, they're usually gonna give you this graph. So this graph is for an alternating current generator. As you can see, the current goes into the negative. I'm sorry, the voltage goes into the negative to show that the current is actually alternating. Sorry, the voltage is alternating as time goes on. So it's gonna produce something like this again. So that's how you know that this is an alternating current generator. When it's a direct current generator, it's gonna be something along the lines of this. It doesn't go to the negative. It only stays in the positive. So the first question, they want you to write the maximum or peak output voltage of the generator. So just from the graph, because they said peak, you can either choose your 340 volts or your negative 340 volts as your maximum. Whichever you choose is correct. And now they say a stove is connected to a generator above, which produces 340 volts at maximum. And it delivers an average power of 1,600 watts. So they want you to calculate the root mean square voltage that's delivered to the stove. So what you must know is that the root mean square voltage, which is VRMS, is equal to the maximum voltage divided by the square root of 2. So this is also going to be a fairly easy question to answer. Can you give me a few seconds so I can go get my calculator? Sorry about that. So your root mean square voltage is gonna be 340 volts divided by divided by let me just check this. Divided by the square root of 2. So that's gonna be 340 divided by the square root of 2. That's gonna be 240 0.42 volts. So honestly, with generators and motors, the calculations are very simple, and the theory, when it comes to the theory, you only have to know the right hand rule and the differences between a AC generator and a DC generator. That's basically what you have to know. So now they say calculate the resistance of the stove. So what you have the power, and now you got the root mean square voltage. and they want you to find, so you have that, and you have your power here. So now they want you to find the resistance. First thing you must do, you go to your formula sheet, you find a formula that relates the power, resistance, and the root mean square voltage. So just off the back of my head, I can see that power is equal to the current multiplied by the voltage, and I'm gonna remove the voltage from Ohm's law. I know that I'm gonna remove the current from Ohm's law. I know that current is voltage divided by resistance. So to remove the current, I'm just gonna substitute voltage and resistance. So I'm gonna have V squared over R when you cross multiply and you make the resistance the subject to the formula, you're gonna end up with resistance is equal to, cross multiply these, V squared over power. So now you're gonna use your root mean square RMS. So you're gonna use your root mean square voltage and your power. So you're gonna have 240.42, the whole thing squared, and you're gonna divide it by 1,600. 600 watts. So 240.42 by 1,600. That's gonna give you, your resistance is gonna be 36.13 ohms. So that's basically the entirety of question 10 done. So do you have any questions?
No, sir.
Okay, but like now, do you have like an idea of on how you're gonna work with generators and motors?
Yes, sir.
Yeah, so basically just keep in mind they're gonna give you the formula. They only want to know the principle. And if they're gonna ask you any other question other than the ones that are asked here, they're gonna ask you the difference between an AC and DC generator. And that difference is here, is with the rings that are used. With an AC generator, you use sling rings. So that's why like there's two of them. But with a DC generator, you're gonna have split rings. So it's sort of like one ring that's split in half, and there's this space between them. So that's the main difference between the two types of generators. So let's go to this Newton law question. So if a person pushes a lawnmower of 15 kg mass at a constant speed on a straight line over a flat grass surface with a force of 90 newtons, the force is directed along the handle of the mower. The handle has been set at an angle of 40 degrees to the horizontal, and they gave us the diagram. So the first thing they ask you is to draw the free body diagram of the lawnmower. So you're gonna have the mower, and the most obvious force is the force of gravity, which is your weight, and you're gonna have your normal force going perpendicular to the surface. So you're gonna have your normal force there. And so they actually did not say anything about, oh, okay. So since they did not mention that the surface is frictionless, you have to assume that there's actually going to be friction affecting the mower. So since he's pushing the mower in this direction, friction is going to oppose the motion. So you're going to have your friction, and in this case he's moving the mower in a constant mass, so you're going to have your kinetic friction. So kinetic friction. And now you have to look at the force applied. So this force is applied at a 40-degree angle to the horizontal. So that means you're going to have your x-axis here. And this is going to be a 40-degree angle. And this is going to be a force applied. So now, they say, why is it correct that the moving lawnmower is in an equilibrium? So the lawnmower is at an equilibrium because it's moving at constant speed, meaning that the net force applied on the lawnmower is going to be zero. So that's why it's correct to say that the lawnmower is moving in an equilibrium. Now they want us to calculate the magnitude of the frictional force acting between the lawnmower and the grass. So in this case, we're gonna have to find our we're gonna use our horizontal forces. So that means we're gonna have to use our x value for the lawnmower. So the x value for the force applied and our friction. So we know that F net is equal to 0 because the mower is moving at a constant speed. So there's no acceleration. And we know that F net is also equal to the force applied minus the frictional force. Okay, let me just say force applied x, because we're gonna have to use our x values. So since F net is gonna be 0, since F net is gonna be 0, I can say that the force applied on the horizontal is equal to the kinetic friction, because you're just gonna take this, move it to this side, and you'll no longer have it here. So now we know that our kinetic friction is gonna be equal to the x component of the force that's being applied. So our kinetic friction is gonna be equal to 90 . If it was like this, it would have been cos 40. So we know that angles on the angles on the Cartesian plane, they are going anti-clockwise. So it's not going to be clockwise, it's going to be anti-clockwise. So I usually use this to my advantage, because I can actually measure the anti-clockwise angle and I don't have to use the clockwise angle. So what I can do is say it's 90 the cos of 40 degrees, sorry, 360 degrees, because this angle is actually going to be 360 degrees minus 40 degrees. So that's going to give me 320 degrees. So your kinetic friction is going to be 90 the cos of 320 68.95 newtons. So either way, if you want to use 40, you'll still get the same answer. If you want to use 320, you'll still get the same answer. And we know that our kinetic friction is negative, so all you have to do is say, to show it, if you already set out a plane that right is negative, left is positive, sorry, right is positive, left is negative, up is positive, and down is negative, you can just write negative here, or you can just say, if you don't want to use signs because it's a bit more confusing that way, you can just say to the left, because if you're looking at the picture, you can see that he's pushing the mower to the right, so you can say that your kinetic friction is to the left. To the left. So do you understand so far?
Yes, sir.
Okay, so what's gonna happen now is that I'm gonna end the session. Then when we come back for our next session, we're gonna answer the 6 mark question and possibly the 4 mark question for Newton's law of universal gravitation. So let me just end this fast.